Okay, 3.5 in your textbooks, we're dividing polynomials. So if you guys recall from elementary school, long division, we're going to do a similar thing but with polynomials instead. It's a bit of an interesting lesson. It is quite confusing if you don't pay attention today. You'll very quickly be lost, but like all the lessons, it's actually not that bad if you guys are alert and paying attention today. So the important thing about this, we all know, or maybe we don't, but if we remember long division, we have the number that's being divided, which we call the dividend, underneath this kind of square root symbol. And then we have the divisor, so what's doing the dividing on the other side. And then we have the quotient on top.
Pardon me, teachers, I'm sorry. Could all grade 10 classes please make your way to the gym now and leave your bags in your class in full uniform and lock your doors?
So these words are important. It's important you know what each one of these words refers to. Okay, so when I say 20 divided by 5 is equal to 4, you understand that this is the quotient, this is the dividend, and this is the divisor. Okay, that's important. All right, that's going to be a communication type question. So that's really the only important thing here. And then just to remember how we do this, right? So 4 goes into 1 0 times, so I can't put anything there. 4 goes into 10 2 times, so I put a 2 up here. And then 4 times 2 is 8, so the 8 goes below 10. So then 10 minus 8 is 2. 4 goes into 27, sorry, 2, and then you bring down the 7, so 27. So how many times does 4 go into 27? 6, so you get 24, and then there's a remainder of 3. Okay? So how that breaks down into an actual kind of formula similar to this is right over here. So 107 is equal to 4 times 26 plus 3. Or another way of writing it is 107 divided by 4 is 26 plus 3 over 4. Any questions about how I went from this to this and this? Because kind of conceptually that's important when we get into polynomials. You guys understand these two equations based on this? Okay. Okay, sure. So we're doing 107 here, dividing it by 4, and we get 26 with a remainder of 3, right? You understand this, right?
Pardon me, teachers, could the grade 9 classes please make your way down to the gym now? Grade 9 classes?
Okay, so just writing that out in a different way then, Alex, is we're saying 107 divided by 4 is 26, and there's a remainder of 3, which has also been divided by 4. Because that 3, remember, it's a remainder, but we've also divided it by 4. Okay? Or you can think of it this way. 107 is actually equal to 4 times 26 plus 3. And notice how these two equations are the same. Okay? I've just divided this by 4. If I divide this by 4, I get 26. Here I get 3 over 4. And here I get 107 over 4. Okay? So these two equations are the same. You see that, right? Yeah. Okay. All right. So next it says selecting a strategy to divide a polynomial by a binomial. Okay, so this right now to all of you guys is probably a little bit scary. This looks a little confusing. Okay, hopefully at the end of today this is going to look like a piece of cake for you guys. Okay, and like all of kind of the math lesson, there's a hard way, which we do first, right? And then there's the fast, easy way. I'm going to show you both, and then after today you'll only be responsible for kind of the quick way, okay, the fast way. I won't make you do it this way, all right? But it's important that we show you this way so you can see the logic behind the quick way and the mechanics. Okay, so the setup is the same. We put the dividend underneath that kind of square root bracket, and then we put the divisor on the outside, same way we normally do. And then it works the exact same way as long division, okay? So we need to get something below 3x cubed. We need to get something down here. We want to get 3x cubed down here so we can minus them. Okay, that's the kind of goal. So rather than dividing it directly into it, we want it. Well, we are going to divide it into it. So 3x cubed divided by x is what? Yeah, 3x squared. So I'm going to put that 3x squared up here. It's very important, okay? One of the areas that a lot of you guys will make a mistake with this is not lining up the exponents correctly, okay? So the 3x, or the cube column is here, the square column is here. So you wouldn't have wrote the 3x squared over here. It's very important that you keep them lined up. Okay, so notice how the 3x squared, we wrote it over here. Okay, we don't think of that too much when we're doing the old school long division, but you are still actually lining them up. Okay, when you do it, you just don't really think about it too much. Here, it's very important. If we get a polynomial, and we will have an example like this later, if we get a polynomial that looks something like this, 3x cubed minus 7x minus 1, if I were to now write this into a long division, it would look like this. So I would actually insert 0x squared just as a placeholder, okay, so I don't mess up the division. That's very important. Okay, we're going to show that a bit later, but I just wanted to stress that now. Because you have no missing gaps here, you have a cube, then you have a square, then you have a single exponent. We don't need to put a 0x squared in there. Okay, but if you had a situation like this, where this was the dividend, you would have to insert a 0x squared. All right. So 3x cubed divided by x is 3x. We put it up here. Now we're going to multiply this 3x squared times this whole binomial now. So down here I'm going to have 3x cubed and then minus 15x squared. Okay, these cancel. Negative 5x squared minus 15x squared, because remember we're subtracting these. Oh, sorry, 9. My bad. Negative 5 plus 9 is 4x squared. Any questions up to here? 3x squared times negative 3. So negative 9x squared. Sorry, because you divide it to get the first term, so these terms cancel, and now you have to multiply this times the binomial to get the full product. Okay?
So how did you get 3x squared again? Did you just multiply?
I took the first term, 3x cubed, and divided it by x.
Just x.
Yeah, because remember, the goal here is to like cancel out, right? So the first term is the one I'm trying to cancel out, and then the second term is what I'm left with. It's the product of this times the second term. Okay, any questions there? All right, so now I have 4x squared. What am I going to do next? I'm going to divide that by x. All right, so then I have positive 4x. Positive 4x times x now. 4x squared. And then 4x times negative 3 is minus 12x. So these go. And I have, this is negative 7x, drops down. So negative 7x plus 12x is 5x. Now up here, I'm going to have positive 5. So I get 5x minus 15. This negative 1 drops down. That's right, yeah. So therefore, 3x cubed minus 5x squared minus 7x minus 1 divided by x minus 3 is equal to 3x squared plus 4x plus 5 plus 14. Any questions? Yeah.
So you see the part where it's negative 12x? Will there ever be do you know how you add it? Will there ever be a time where you're subtracting those two numbers?
You are subtracting. So negative 7 minus negative 12. So it's negative 7 plus 12 is 5.
It's always so it's always subtracting?
Yes. Just like you would in regular division. 10 minus 8 is 2. Yeah, we're going to do it a bunch of times. It looks crazy, but it's not. It's not. Yeah.
You don't add the positive 5 and the positive 14.
The positive 5 and... Sorry? Ask that again?
Why don't you add the positive 5 and the positive 14 on your final
Here?
plus 19?
Yeah, you could. Yeah. But then if I expand this, I'm going to get back to this, right?
You can't just put it in because
No, you could. Yeah, you could. Oh, sorry, hold on. No, you can't, because this is equal to this. Yeah, because of this equation, right? I have to times it by the divisor. Yeah, sorry, good question. You can't add that 14 because it's this times this with the remainder of 14.
So
Yeah.
to write the formula, do we need to put x minus 2 as exponent? Or not? Like, you know how you put x minus 3, let's say multiplied.
Yeah.
Do we need to write that in the final equation or not?
Yes. Yeah. Yeah, let's do a couple more examples. It'll make more sense. It's not that bad. All right, guys, bear with me. We'll go through a couple more examples, and it'll make sense. It's not that hard. Okay, so here's what we ended up with on the other page, right? Here's the process a little bit neater. Okay, I'm just going to go through it again quickly. So the first term we get, we do 3x cubed divided by x is 3x squared. We put at the top. Then we multiply both terms of the binomial by 3x squared. Okay, we end up with negative 3x squared plus 9x. Thanks. There's a mistake here. This should have been,
Why does it go to 12 at negative 12?
they put the negative sign in right away. That's different, but it's the same answer, right? So rather than doing, okay. Okay, guys. See how this is 3x squared minus 5x squared minus this? They put the negative sign in and then added them. So they made that negative 3x plus 9. Do you see that? But it's the same thing, okay? That's a little confusing there, okay? I would have just left it like this, okay? Let's see if they did the same thing here. 4x squared minus 12. No, they didn't do it here. So now they didn't do it that way. So that's a little confusing, yeah? Okay, now they're doing straight minus. So negative 7 plus 12 is 5x, okay? All right, believe me, when we go to the easier way to it, the whole thing will be easier, but it's not that bad. Sure, you want to do a regular solution first? Okay. Okay. So here we have a polynomial divided by a trinomial now instead of a binomial, so that stays as the divisor on the outside. Okay. It's okay. Don't worry. This, Luke, you're gonna get it. Okay. Just hang in there. Okay. Sorry.
Are we going to do E?
We are. Luke asked to do the long division way, and then we're gonna go back to B. It's the fast way. Okay. Not a bad idea though to just look at this one more time. Okay. So we put the dividend underneath the square root sign, or the divisor sign, the divisor on the outside. So the first step is we have to take the leading exponent, or the one with the highest degree. Sorry, I should mention that you have to reorder the divisor. Okay, see, notice how here in the actual question, the x to the exponent of 4 is on the end. You can't have that. It's going to mess everything up, okay, if you write that underneath the square root. You have to reorder it in the order of the exponents. Okay, does that make sense?
Yeah.
Okay, so we've written that 4x to the exponent of 4 minus 2x cubed, plus we inserted a 0x squared, like I did on the last question I was showing you. If that happened, if you're missing one, you have to put it in. Okay, that's important later as the order gets reflected. Okay, and then we have the 5x and finally the 3. Any questions about that? How I've reordered this and inserted the 0?
So which, is that the square that you inserted? Because there's no square that...
That's correct. Yes. See, 0x squared. Okay, this is going to make sense, guys. Now we have to get x to the exponent of 4. So we divide x squared from x to the exponent of 4, and we get x squared. So we have to put that in the square column. So we put x squared over here, x squared times x squared, and now we line them up. Is x to the exponent of 4, x squared times 2x is 2x to the exponent of 3, x squared times 1 is x squared. Okay? Any questions there? All right, so you've multiplied that. Now we just subtract. So these go away. Negative 2 minus 2. No, negative 2 minus 2 is negative 4, right? Not 0. Okay? So you're left with negative x cubed. Then you have 0 minus 1. So we get negative 1 x squared. Drop the 5 down.
So why are you subtracting and adding?
Because that's the way you do it. You subtract this, right? You're always subtracting. Never adding.
No, well, why are you adding? Why is the book adding?
Because the book switched the signs and added. I don't know why it did that. And that's why I put a question mark and said it shouldn't have done that. Any questions up to here? Marco. Okay, so now we have this trinomial. We drop the 5 down. So our next step is going to be what? We got to get to negative 4x cubed. So we divide x to the exponent here, divide it out of this, so we're going to end up with negative x to the exponent of 3, and we do that by putting negative 4x here. Okay? So the goal is to cancel this term out, right? So what needs to multiply to x squared to cancel this term out? It's 4x, okay? So you take this term, you divide it by x squared. You're left with negative 4x. So that goes up here. Now the negative 4x multiplies by this term and gives you that value you want, okay? Now you subtract these. Negative 4x times the second term is negative 8x squared, and then negative 4x times 1 is negative 4x over here. Okay, now you're subtracting these. Negative 4x minus negative 4x is 0, so these go. Negative 1 minus negative 8 is positive 7x squared, and then 5 minus negative 4 is 5 plus 4 is 9x, and then the remainder comes down 3. And you do the same thing again. So we want 7x squared divided by x squared. It's 7. 7 times x squared is 7x squared. 7 times 2x is 14x. 7 times 1 is 7. Okay, subtract them, negative 5 minus 4. So our remainder now is actually a binomial. Okay, there's 2 terms of the remainder. There's nothing else we can do here because there's nothing else to drop down. Any questions there? So our final equation then looks like this. The dividend is equal to the quotient, which is here, the quotient times the divisor, plus the remainder. So plus negative 5x minus 4, they just took out the plus and just left the negative 5x minus 4. Any questions there? Making a little more sense? All right, that'll be the last time you do that now. Now you're going to use the quicker way.
So it's our choice to use.
You can use either or. Okay, here's the fast way now. So the the question is the same as the first example. So we're dividing by the binomial x minus 3. So in synthetic division, x minus 3, the binomial or the divisor is always of this form, x minus k. So k actually changes signs, right? So k is equal to 3 in this case. K is equal to 3. Okay? That's just one thing you have to remember. It's similar to when you have x-intercepts, you reverse the sign when you have them in binomial term. So k is 3. So you put 3 on the outside of this L bracket. And then inside the L bracket, you put the coefficients of the dividend. So this 3 is from here, this negative 5 is from here, this negative 7 is here, and this negative 1 is here. Any questions about that? All I've done is put the coefficients. Again, very important, if there's a missing term, like no x squared, you'd have to put in 0 here, because this order is extremely important. It has to stay in order from highest to lowest exponents. Okay? So if there was a term missing here, I would have to put a 0 in here as a coefficient. Okay? Alright, so once I've done that, I've set everything up. The first step is you drop the first term down. Okay? It becomes 3 here. Next step, you multiply by the value of k. So again, k is the opposite sign of the binomial divisor. It goes up here, 3k. So 3 times 3 is 9. Now you add these two. You don't subtract. So it's the opposite of when we did long division the traditional way. We're adding these two. So negative 5 plus 9 is 4. Okay, you have to do this first before you can go to the next step. So you add them. So now you have 4. You're going to multiply that 4 times k again. So here we see this step. 4 times 3, 12. Add them. Negative 7 plus 12 is 5. The 5 times k again is 15. Add them, 14. Okay? Stay with me here, because this is the method you're going to use. Okay? If you're confused about it, believe me, if you said, well, I understood long division, I'm just going to use that. No, you want to use this. Okay? So if you're confused, ask me now. Okay? This is tremendously easier. Okay? So it might look confusing at first because there's no variables, but believe me, this is going to be the quicker way. Okay, then you add the last two and your remainder is 14. Okay? When you go to write the equation out now, these are your coefficients, and you just start with one term less than what you started. Okay, that's how we know. So we started with 3x cubed. My first term is going to be squared. That's the only difference. Okay, and then there's your coefficients, 3, 4, and 5. Yes, and you just go down. This is your square column, this is your x column, and this is your number column. And then you have a remainder of 14. So there, we're done. There's the answer. Okay, we're going to do that other one that was really long.
So what if the divisor was like an x squared?
We're going to get there, okay? Hold on. Let me just finish this. Okay, so watch this. We're going to do this one now using synthesis. Okay, I'm going to need some help here. Sorry, this one we can't do with synthesis because our divisor is a trinomial, so we don't just have a value of k. So that one won't work.
You can't factor out or anything like that?
It only works when you have a binomial k value, because there's actually two factors you're doing in one.
So we're gonna need to know how to do the long division. Yeah.
If you're dividing by a trinomial, yes. Yeah. Sorry. I don't know if there's many trinomial divisions though. It's all binomial division. Okay, look how quick this goes now. So we have a binomial divisor. Here's our dividend. Notice how it's out of order. So the first thing we have to do is rearrange it. Okay, So we do that x to the exponent of 4 minus 2x to the exponent of 3. There's no x squared term, so I have to put in 0x squared here, plus 13x minus 6. Okay, so there is my term now, and I want to divide that by x plus 2, so my k value is equal to negative 2. So I put negative 2 up here, and then I put the coefficients that I've created by rearranging here. So 1, negative 2, 0, 13, and negative 6. Any questions there? So watch how quick this is now. So the first one I drop down is 1, times it by negative 2 is negative 2. I add these two, I get negative 4. Times it by negative 2, I get positive 8. Add it, 8 times by negative 2, it's negative 16. Add them, negative 3. Times it by negative 2, I get positive 6. Add them, 0. So now my coefficients are, again, starting with one lower, x cubed minus 4x squared plus 8x minus 3. Okay, and you're done. Any questions?
So what if the quotient has like it doesn't have x squared, it just has x cubed minus 4x and then 8x.
Yeah, that's what happened here. There's no x squared. So we put in a 0x squared.
Yeah, but how would you know that it'll have that in the quotient? Like it's always gonna be at 3 to 1. Like the exponent.
I'm not sure what you're asking.
Okay, so you know how you said for the quotient needs to go lower for the exponent, like 3 to 1 right there.
Here, yeah.
No, the quotient.
Here?
Quotient down there.
Here, yeah.
Yeah, so you know it's 4x cubed plus 8x squared. X cubed minus 4x squared plus 8x. What if there was no?
You just don't put it in. You just don't put it in.
How would you know that?
You'd get a 0 here.
Oh, okay.
Okay? All right. Number 4. So now we're taking this dividend, we're dividing it by this binomial. It's important that you factor out the 2 before you start so you can get a k value. Okay, so you need to put it in this form. So notice it's 2x plus 3. I'm going to factor out the 2. So I'm left with x plus 3 over 2. Now my k value is negative 3 over 2. Any questions there? Okay. So now I set up synthesis. So k is my negative 3 over 2. I drop the 6 down, multiply 6 times negative 3 over 2. I get negative 9. Add these two, negative 4. Multiply by negative 3 over 2. I get positive 6. Add them, negative 10. Multiply negative 10 by negative 3 over 2. I get positive 15, and I get 0. So these are my coefficients now. So all of this, these are my coefficients. So the only thing you need to remember, if you divided 2 out at the beginning, you need to take those coefficients and divide them by 2. So your new coefficients are here for the original term. Okay? So that's what all this is. We're just taking these coefficient terms and we divide by 2. Why? Because we divided at the beginning. We factored out the 2. Okay, so we're just factoring out the 2 now of the answers. Okay, so that's why you're left with these values. Okay, so 6x cubed plus 5x squared minus 16x minus 15 divided by 2x plus 3 are this value now. And again, these come from these coefficients that we determined, just dividing each one of them by 2 because we divided the original divisor by 2 at the beginning. Okay, so we're just repeating that. Any questions there? All right, next we have this set up where we can actually factor the trinomial quotient. Okay, so we ended with this term, we should say that this term is familiar to us, and we can actually use factor by inspection and factor this term out to two other terms. Okay? So we should all know how to do this. What multiplies to negative 15 adds to 2, use cross and inspection. Okay? And so we get 3x minus 5 multiplied by x plus 1. Okay? Why is this important? The reason we do this and factor it out like this is so that we can find the zeros of the graph. Okay? So the zeros now become negative 3 over 2, 5 over 3, and negative 1. That's why we have to factor out that trinomial. Okay? Any questions there? It's the whole point of this. The whole point of this factoring and this dividing is to find, what's going on and what's happening on the graph. Okay? Once we have those zeros, we can plot them. Okay, and then we know what the end behaviors are based on the degree and the coefficient. Okay, the degree is odd, so they go opposite directions. It's positive, so we know it ends up going this way. And we plot those zeros. Okay, any questions? No questions there? Okay. Okay, so in summary, the polynomials can be divided in the same way that numbers are. That's long division. It can be divided of the same degree or less. Can't divide it by a greater degree. Okay, because you would get a decimal value in regular numbers. In this case, we're not going to be able to do that. Okay, so I won't ever give you a divisor with a higher degree than the dividend. Synthetic division is a shorter form of polynomial. It can be used when the divisor is linear. That is x minus k or ax minus k. When using polynomial, let's go back. No, my bad. When using polynomial or synthetic divisions, terms should be arranged in descending order of degree, so their exponent value. In both the divisor and the dividend, to make the division easier to perform, 0 must be used as the coefficient of any missing powers. This is important, right? If the remainder of a polynomial or synthetic division is 0, both the divisor and the quotient are factors of the dividend. Anybody knows what this means? Nobody? So all this is saying is, yep. No, there is no remainder. It's saying if the remainder is 0. So all they're saying is if you have, let me give you an example. Okay, I'll just make it up. This won't work. But if you had, let's say this. And we got an answer equals let's say we had that and it was a perfect remainder. It's saying that both of these now are a factor of this. Why? Because if we went the opposite direction, we can say that this multiplied by this is equal to the original. So that's all it's saying, is that if it divides out evenly, they're both factors. Remember what a factor is. It's just something that can be multiplied evenly by something else to give you the original dividend. Okay, that's what a factor is. Like 15 divided by 5. 5 is a factor because 5 times 3 is 15. Okay? That's all this means. Okay, and that's it.